Hello friends. So we have covered KVL, KCL, ideal and practical voltage and current sources. Then we have seen star delta transformation. We have seen mesh and nodal analysis. Now before moving to the theorems, which is an important point or important topic of this chapter, I will revise mesh and nodal analysis once. I will solve one example on mesh and one example on node each, and then we'll move for the theorems. Okay, so this is the practice example. First we'll solve a mesh example. Actually, question is given as a by mesh analysis find uh, okay, I will write on the circuit first so that you can understand the question. Now, as you all know that by using KVL, that is mesh, we find current, and by using KCL, that is a Kirchhoff's current law, we actually find voltage. Okay, now this is the circuit. 6 ohm, 2 ohm, 5 ohm. This is voltage V, which is not given. 1 ohm, 3 ohm, 4 ohm. This is 20. Now general thing is this voltage should be given and they can ask current between any resistance. Okay, you can simply apply KVL in all three loops like this. You can assume any direction. You can find I1, I2, I3, and if they ask current between two, then it is I1 minus I2. Okay, this is I1, this is I2, this is I3. Okay, if they ask current through 6, it is directly I1. Okay, but now the twist is they have asked what is the value of voltage. By mesh analysis, find the unknown EMF V in the network which causes mesh current I1 to be 0. Okay, we want voltage V such that this current I1 will become 0. Now let's apply KVL in first loop. So it is, from here I will start, minus 6 I1. Okay, polarity like this, plus minus plus minus plus minus. For voltage polarity will remain as it is. Minus 6 I1 minus 2 I1 minus I2 minus 5 I1 minus I3 minus V. Okay, it is unknown, so directly I will write V plus 20, this plus 20 equal to 0. Or if I rearrange, I will get it as a 13 I1 minus 2 I2 minus 5 I3 equal to 20 minus V. Okay, now let's keep this equation as it is, this first equation. Let's apply KVL in second loop. So polarity plus minus plus minus plus minus, new polarity, forget about previous one. I'll start from here. So it is minus 2 I2 minus I1. I1 and I2 are in opposite direction. Minus 3 I2 minus 1 I2 minus I3 equal to 0. Right? Now if you solve it, this is loop 2, loop 1. Okay, so when you solve it, you will get 2 I1 minus 6 I2 plus I3 equal to 0. Now apply KVL in loop 3. Let's apply KVL in loop 3, means this loop. Okay, now in this loop again new polarity, plus minus plus minus plus minus. So let's start from here. So it is minus 1 I3 minus I2 minus 4 I3 plus V minus 5 I3 minus I1. So when you solve it, you will get it as a 5 I1 plus I2 minus 10 I3 equal to minus V. Okay, now here there are three I1, I2, I3, three unknowns. This is second equation, this is third equation. Okay, now we want mesh current I1 is to be 0. Here we want I1, we want voltage such that I1 should be 0. Now what we can do, Simple. You can solve it in a calculator or you can go for a Cramer's rule. Cramer's rule. How to find out Cramer's rule? Arrange all these in a delta fashion, matrix fashion, coefficients. Okay. So for I1 it is 13, for I2 minus 2, for I3 minus 5. Similarly, in second equation 2 minus 6 1. In third equation 5 1 minus 10. I1 I2 I3 equal to, here it is 20 minus V, it is 0, it is minus V. Okay, now determinant, you know determinant, it is 13 into these two multiplication minus this. Okay, 60 minus 1, then minus b, minus minus means it will become plus 2, then multiplication of, leave this row and then multiplication of these two is minus 20 minus 5. Similarly here minus 5 and 2 plus 30. You know this, how to find a determinant, no? That is called as a del. Okay, now how to find out del 1? For del 1 we have to replace our coefficients of I1 with these constants, right? So what they are saying, del 1 by I1 is given by del 1 by del. How to find out I2? Replace coefficients of I2 by this constant and find out determinant, that will be del 2 divided by actual determinant del. How to find out I3? You know this in a mathematics. Replace all the coefficients of I3 by constant. Okay, find out determinant, that is del 3 divided by our actual determinant del. But I1 should be 0. We want I1 to be 0. Okay, so what I can write? Replace coefficients of I1 with constant. 20 minus V, 0 minus V. Here minus 2, minus 5, minus 6, 1, 1, minus 10. Okay, now what they have asked, del 1 by del should be 0. So I can say this determinant is 0, right? Because del is not 0, no? Del has some value. So del 1 should be 0. So this is 0. Now by take a determinant, 20 minus V multiply by minus 6 multiply by minus 10 minus 1 into 1, that is 1, minus minus 2 means it will become plus 2. In similar fashion what I have shown just now, 0 into 10, that is 0, minus 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 it will become plus, 0 minus minus v, that is plus v. Okay. Lastly minus 5, 0 minus 6v. So 0 minus this minus minus will become plus, so minus will remain as it is, 6v. Okay, now we equate this with 0 and if we solve, there is only one unknown, that is v. You will get it as a 43.7 volt. Okay, this is some I can say complicated or some difficult type of example where instead asking simple question, they have asked you a tricky question, right? Now similarly you can solve any example. Let me see another. Now if there is another example, I will just give you the hint, I will not solve complete example. Two, 6, 19, 1, 2, 25, 3, 1. This is I3, this is I2, and this is I1. Now you have been asked to find out current in this 2 ohm resistor. Find out current in 2 ohm resistor. So what you have to do? Apply KVL in all three loops. Okay. So in first loop you can find out from here if you start. is 25 minus 2 I1 minus 1 I1 minus I, sorry, this is I2, this is I1, no? So I2, 25 minus 2 I2 minus 1 I2 minus I1 minus 3 I2 minus I3 equal to 0. This is first equation. Okay, this is in the second loop. In first loop it will be, if I start from here, minus 2 minus 6 I1 minus, sorry, plus 19 minus 1 I1 minus I2. This is second equation. And here in third loop, this is loop 1. In loop 3, it is, if I start from here, minus 19. For voltage never multiply with current, it is already given voltage drop. We are doing this voltage addition. Algebraic sum of voltages in a closed loop is 0. 25 is the voltage, and here voltage is not given, so we are multiplying resistance and current. 19 is directly voltage, so don't multiply with current. 19 minus I3 minus 3 I3 minus I2 equal to 0. Now solve these three simultaneous equation, you will get I1, I2 and I3, and from 2 where they have current through 2. So I2 is directly passing through 2. So current I2 is nothing but the current through 2. Okay. Now we will solve one example on nodal analysis. I will take difficult example. In nodal, what we have to do? First, identify the nodes. Junction where more than 3 or more than 3 branches meet. First, identify the node. Then, assume voltages there. Then, assume all currents moving in outward direction. Okay. So, we can see this is 28. This is 2, 5, 4, 2. This is 2, this is 1, this is 10. Okay, so assume the junction, this is 1, this is 1 and this is 1. This is ground potential. In nodal, don't take ground potential. Okay, this is, though it is junction, though don't consider it. So I can say this is V1, this is V2, this is V3. Okay, assume all outgoing current. Now this is already incoming, so forcefully I will not make it outgoing. Remaining I will consider outgoing. So at junction 1, node 1 I will say. At node 1, KCL is 28 equal to this current. This is I1, I2 and I3. So 28 equal to I1 plus I2 plus I3. Right? So what is I1? I1 is current in this branch. So V1, voltage by resistance. No? So V1 minus 0 divided by resistance. So V1 by 2, or directly I can write down. What is current in this branch? Voltage in this branch divided by resistance by Ohm's law. So what is voltage? V1 minus V2. So V1 minus V2 divided by 2 plus V1 minus V2 divided by 2. Similarly, what is voltage in this branch? This branch is resting at this terminal. So consider this terminal. So V1 minus V3 divided by 10. V1 minus V3 divided by 10. Okay. Now if you solve it, it will be 11 V1 minus 5 V2 minus V3 equal to 280. First equation. Now let's apply KCL at second node here. Okay. Forget previous directions. Now again fresh directions outward. So now I can say uh, this is I4, I5, I6. I4 plus I5 plus I6 equal to 0. I4 is, this current is V2 minus V1 by 2. V2 minus V1 by 2 plus this current is V2 by 5. V2 by 5. And this current is V2 minus V3 by 1. V2 minus V3 by 1 equal to 0. Okay. So when you solve it, you will get 5V1 minus 17V2 plus 10V3 equal to 0. Okay. node 2, this is node 2. Now at node 3 here. Okay, again this current is outgoing, so I will keep as it is. Remaining current I will assume outward. Okay, forget about the previous direction. So I can say all outward current, so I can add them simply. So I7, I8, I9. I7 plus I8 plus I9 plus this is 2 ampere, 2 equal to 0. So what is I7? This current. So V3 minus V2 by 1. V3 minus V2 by 1. What is I8? This current. So V3 by 4. What is I9? This current. So V3 minus V1 by 10. V3 minus V1 by 10 plus 2 equal to 0. Now if you solve this equation, you will get it as a V1 plus 10 V2 minus 13.5 V3 equal to 20. This is second equation, this is third equation. Now simple thing, solve these three simultaneous equations in a calculator, okay, and you will get answers as a V1 equal to 36 volt, V2 equal to 20 volt, and V3 equal to 16 volt. You got the voltages. But what was the question? Question was to find out the current in each resistance. Okay. Now simple thing, you can find it out by your own. If you want current in this resistance, what it is? V2 by 5. V2 you are having. So 20 by 5, it is 4. 4 ampere is flowing here. If they ask current in this resistance, then what it is? V1 minus V2 by 10. Okay. So see, V1 minus V2, it will be 16 by 10, 1.6. 1.6 is current. Similarly, you can find current in any branch. Okay. Thank you. From next lecture, we will start theorems. Thank you very much.